Hello and welcome to Wednesday's math class. Guys, we're already in May, so we're almost to the end. The last day of school is May 29th, so we've only got a few weeks left. So you guys made it. I'm proud of you. I'm proud of how resilient you've been through all this crisis, and we're going to get through this together. So I've got 50 people here today, so thank you so much for coming in. Thank you for joining live, those of you that are watching this live. And I'm really happy to see that. Okay, so one second here. Let me go ahead and pin my video. Oh, okay, there I am big now. All right, so just a few things before we get started. I want to remind you guys that that we're on the new schedule, and that Friday, that means that Friday all of your work is due on Friday. For most of your classes, it's at 11 a.m. I think for Ms. Kara's assignment, it's at 2 p.m. And you do have a test in her class. So any tests and quizzes are given on Friday. Okay, so make sure that you go on there on Friday between 11 and 2, and you take that test and any other tests or quizzes that any of your other teachers may say that you have. Okay, in my class, you do not. I tried to give them a week of being able to do it so that I'm not stealing the show all the time. So you don't have to worry about math quizzes, but you do have a math assignment due on Friday. So let me let a few stragglers in here, and I'm going to share with you the PowerPoint. And we're going to get started learning a little more about statistics. In fact, this is the last lesson of statistics that we're going to be learning. So we just have a little bit more to learn about histograms and about statistical questions, and then we are moving on. Okay, and we're going to have some time to also review a little bit of the stuff that we've learned this year on algebra, and then we are going to also start getting ready for 7th grade. Okay, so we're going to do some 7th grade prep. So that's always fun. Some skills that you're going to need to know about adding, subtracting, multiplying, dividing integers. Those are those positive and negative numbers. And so some cool things that we can look forward to. All right, so today, just to check in with you, again, your IXL, the same IXL skills that I assigned on Monday, okay? There's nothing new. Those IXL skills are due by Friday at 11 a.m. Now, my goal is that this week, I'm not going to have to track a bunch of people down that don't do it on time. Okay, so I'm going to be a lot stricter with the cutoff. So make sure that by Friday at 11, and if you know that you're someone who likes to sleep in, which you came here at 11, so I'm guessing you're not one of those. But if you are listening to this later in the day and you like to sleep in, then make sure that you've done it the night before. Okay, because you know that it's due at 11 in the morning. So you're going to have to do the IXL skill that I assigned about interpreting histograms. And whatever you end at, that's going to be whatever SMART score you end on, that is your grade. Okay. And that's out of 100, guys, which is a lot. That's twice the amount of points that the box plot drag and drop activity was worth. So this is a chance for you to like really increase your grade there. And then if you also want to keep on increasing your grade and skyrocket that grade up to as high as it could possibly be, there's a bonus credit opportunity as well if you do the interpreting line plot activity, which should be a review that is from last week. Okay, and that would be if you get it up to 80, then you'll get 4 points added to your quiz grade. If you get it up to 100, you get 6 points added to your quiz grade. So that's a great opportunity for you there. Okie dokie. So, all right. So anyway, let's go on to EDSB for a second here. So I'm going to go ahead and do a share to EDSB. And we are going to take a look at a couple things. Let me just get out of this. All right. So make sure you're entering all your classes, and you should see all this. This is today's It's green. So today's post is green because it's Wednesday. Some important things, if you have not already, please pull up this right here, Guided Notes, Creating Histograms and Statistical Questions, either the printable version that you print, okay, if you have, you can, you know, click print if you have ink, or the editable version that lets you type into it, okay? So either one, go ahead and do that, and they are found right here. One, it says editable and one says printable. Okay, so either you can choose either one, and that's what we're going to be using in just a minute. So go ahead and try to pull up one of those right now. And a couple people say that my screen's blurry. My screen's not blurry on my side. That must mean that it's something to do with the internet. So I apologize if you see a blurry screen on your end of it. Apologize for that. So just give it a minute and hopefully the internet will be nicer to me. Okay, so these are the two things that are due by Friday, bonus and IXL. A lot of you have already done those things. Don't just leave them till the end and then forget about it and then tell me that you forgot about it. So make sure that you remember to do that. I would get it out of the way while it's fresh in your brain. Okay, so this is where you're going to find your notes. Like I said, you need to download either the printable or the editable version of this for today's lesson if you haven't already. All right, so we're going to go back to our PowerPoint here and get started. Got a few things that we need to learn. So we're going to learn about, we're going to do a little review about what is a histogram, and then we're going to get into how do we create them ourselves. And then we're also going to talk about statistical versus non-statistical questions, which is pretty cool. And we're actually going to do practice on that last skill on IXL live. So that'll be neat. And I'm going to need your help for that. We have no math quiz this week. Okay. So just to remind you, same tip to remember that bar graphs show categories, histograms show intervals, ranges, and those are frequency of numbers in a data set. Histograms a lot of the times show information from survey questions or questions that have a varied result in science or in business, okay? Here is some vocabulary. We've already kind of gone over this a little bit last time, but I want to kind of dive into it and show it to you in a different way. The vocabulary shows, I like these. Have you ever seen these before? Where it shows you all the different, like the non-example, example, a picture, all that. So this is an example of a histogram. A non-example would be anything like a pictograph, a line or a dot plot, a box plot, a bar graph with categorical data. Categorical data is data that's in categories, like favorite color, favorite subject in school, those types of bar graphs that you guys did a lot when you're in kindergarten, first and second grade. Those are not histograms. They're just plain old regular bar graphs. A histogram is a type of bar graph that shows the frequency of intervals. So it's data that is numerical, and it's split up into equal intervals. So they have to have equal intervals. They have to have continuous bars that are kind of smushed together. Okay, there's no space in between. And they show, like I said, numerical data. That means data with numbers. And 5 to 8 intervals is ideal. So when you're going to create a histogram, today we're going to create histograms that already have frequency tables, but if you have to create a histogram that doesn't have a frequency table, that means you have to create your own intervals. And that's kind of the hardest part of creating a histogram, is deciding what those intervals, those ranges are going to be. Like these ranges down here on the weights of dogs. If you've got a bunch of dogs and all the dogs weigh between 0 and 69 pounds, you're going to have to decide, okay, am I going to count by tens? Well, you really can't count by tens. It's really like 10 numbers, so 0 to 9 or 1 to 10. Okay, so you got to kind of choose how you're going to number them and make sure that they're all equal. So if you're going to do 1 to 10, then you've got to do 11 to 20. If you're going to do 0 to 9, then you would do 0 to 9 and 10 to 19, and so on. You have to make sure that they're exactly equal. And you want between like 5 to 8, 5 to 10 bars. That's ideal, because you want to be able to show some sort of differences. You don't want them all to be the same. You know, if they're all a uniform is what they call it, they all go straight across, then you're going to want to choose a different amount of intervals, okay? So again, here's just another view of what a histogram is. It starts off with a frequency table where we get to use our tally marks again. You count up the frequency of how many numbers fall within those ranges, and then you create your histogram. See, this has 1, 2, 3, 4, 5 intervals, and so that's a pretty standard histogram. All right, and sometimes we call these intervals like bins, and that just means like a bucket, a bin that we don't know how many are gonna fall into that bin, but it's got an equal chance. So this goes from 50 to 58, and then 59 to 67, 68 to 76, 77 to 85. So they're equal chances for numbers, but then the frequency is not equal, you see. In fact, there's nothing that falls in 59 to 67, but you still have to include that, okay? Because you're giving it a chance to fall. You're giving the numbers in the data set a chance to fall in there, but none do. And that's an important piece of the data set to know, oh, wow, look at that. You know, nobody scored a D, or nobody, you know, got 59 to 67 on the quiz. There was one person that failed, but most of the people were up here, you know, that kind of thing. So it is important to keep that on the histogram and not just delete it. Okay, so we are, I don't know why that went in there. Let me delete this slide. Hold on a second. That's not supposed to be there. All right, so we're going to jump into our guided notes. And those are the notes, like I said, that you either downloaded to print or that you downloaded to enter in. There's some text boxes that you can just double click and type into. Okay, and we're going to basically use the same definition that we used over here, a type of bar graph that shows the frequency of intervals. That's what we're going to go ahead and type right here at the top of our notes. So either double click there, or you could just write it in, a type of bar graph that shows the frequency of intervals. Okay, and you could even put equal intervals in there. Okay, in a histogram, there are no blank between the bars to show that the data is blank. This would be, in a histogram, there are no spaces between the bars to show that the data is continuous. Continuous. This is always a difficult word to spell. It's got those U's in there. Look how close together those U's are. Just freaks you out. Okay, let me let somebody in here. Welcome if you're just coming. We are using the guided notes today. So if you're just walking in digitally, please make sure that you've got the guided notes from EDSB up either digitally or printed out. When making a histogram, data should be divided into intervals. Okay. And we're going to get to the equal part in just a second. Because look, each interval should have the same number of values in it. You know, in math, we love to use that word, values. And it's the same thing as saying each interval should have the same number of numbers in it, okay? The data set numbers are just like values because they are all worth different amount. Each bar in a histogram shows the frequency. Each bar in a histogram shows the frequency. Oh, I lost a text box here, so I'm going to copy and paste one in. I think you guys have it on your end. I just think that I didn't put one on my end. So let me copy and paste. Don't you love copy and paste? I do. Okay, so the last sentence says, in a histogram, the bars must be the same, and this is going to be width. Because what we don't, I'm going to show you what I mean in just a second. We want to make sure that visually we're showing everything that we need to show. And we're making sure that we get, when someone looks at it, we're not giving them any misconceptions, okay? So I'm gonna click back, but if I'm going too fast, I will come right back to the slide, I promise. But I just want to show you guys a visual what I mean by the bars being the same width, okay? So look here. See how the bars are all the same width? If we made one really fat and another really skinny, it would look like we're trying to say something about that data, and we're not. They're equal intervals, meaning they have equal chances. Each of these have 8 numbers in it, so we want to show that they're equal intervals. So visually, we keep them the same width, okay? And that's really important, especially when we have a number line on the bottom of our histogram, that instead of showing the intervals, it just shows like 50. And then at the end of 50 starts 60. And then at the end of 60 starts 70. And if we have that, that's just a straight up number line. And so we want to show that there are really equal intervals. And so the widths would be exactly the same. Now, this is a lot easier to do with things like with this digital stuff. But when I have my kids in class make, one second, I've got a camera on here. I gotta stop. Guys, remember, no cameras on, so you gotta make sure to monitor yourself on keeping your cameras off. Okay. When we're doing this in class, a lot of the times it's really hard for my students to keep those equal intervals, those equal bars, and we use graph paper and we count them out. Oh, okay, when I'm drawing this, this is only gonna be like 5 bars wide on all of them, you know, and you can't just kind of eyeball it. You want to make it exactly perfect. So, and you know how I am about making things just right. So you kind of lucked out by having to do it digitally instead of on paper and pencil. Okay, so that should have given you enough time to write those down. And so let's go ahead and move to the next bit. Creating histograms, the steps, okay? Step 1, create intervals, and I'm going to say equal intervals because that is so important, like I said. Otherwise, your histogram is going to be completely wrong, and we don't want that. Okay, now sort the data into each. You could say bin, you could say, I'm going to stick with the word interval because I think that likes to pop up. That likes to pop up on tests and stuff. So you have to make sure that if you hear the word interval, that it's going to have something to do with a frequency table or something to do with a histogram, okay? Then it says mark the blank, draw blank to represent the frequency. Remember the bars must blank and be the same. Okay, so here it's going to be mark the axes, and axes are like this, okay? And what that means is it's axis, plural, okay? So we're not talking about the axis, the weapon, okay? And it means the X and the Y axis. And what it's saying to do is, again, to kind of like notch out that equal width for each bar, and then also to make sure they're labeled. Like, what is it showing? Is it showing you know, the height of 6th graders? Is it showing the weight of dogs? And then on the y-axis, the vertical axis, you want to mark out what are you going to count by? So maybe your frequency goes from 0 to 100. Okay, well then maybe I'll count by tens. Okay, you got to kind of think. It depends on, every histogram is different. So you have to look at what the results are on the frequency table and then say, okay, it seems like my frequencies are just between 0 and 6. Okay, well then I'll just count by ones. And then you mark it out. And if you're using a graph paper, you would want to make sure that, you know, when you go from 0 to 1, you're counting an equal number of little unit cubes. Okay, like maybe you're going to count 2 or 3 or 5 and make that a new notch. So everything has to be really equal and uniform when you're making any kind of graph. All right, draw blank to represent. This is where the bars come in, okay? Draw bars. And sometimes we like to make the different bars different colors. So today in our activity, I made them different colors because again, that just shows that visual difference. So then when someone sees your histogram, it's easier for them to read it. And so you want to make it as easy for the reader as possible so that they can understand the information you're trying to communicate. Okay, excuse me. Step 4, draw bars to represent the frequency. Remember, the bars must blank. They must touch and be the same blank width. Okay, step 5, and see, these steps are really important when, again, you're doing this paper and pencil, because it's like, oh my gosh, where do I begin? Okay, so it's always good to refer back to these, especially for if you ever have to do it from scratch. Step 5, blank all parts of the histogram. This would be where it says label, and since it's the first word of the sentence, I'm going to capitalize it. Label all parts of the histogram. So everything has to have a label, okay? And I remember learning this when I was doing my science fair projects when I was in 3rd, 4th, and 5th grade. And you guys really haven't done science fair projects at LearningGate too much, but I love them. And I remember learning about the parts of a graph that way. And so you got to make sure you label your x-axis. What is that showing? Again, like I said, weights of the dog, height of 6th graders. And then you have to label your y-axis, which a lot of the times is frequency, is like a generic for a histogram. You could just put frequency, but you could also be more specific. What is that frequency showing? Is it showing the number of dogs that are that weight? Is it showing the number of students that are that height? Okay, so you might want to be more specific and put number of students, number of dogs, okay? Whereas frequency would be like the generic term for it. Okay, and then also you have to label the title. The whole graph has to have a title, okay? And titles are capitalized, okay? Just every word as long as it's a pretty big word is capitalized, okay? Like height of dogs in centimeters, okay? You have to be specific. If it's something that's being measured, you have to include the unit. That's really important. Today we lucked out because I kind of scaffolded this lesson a little bit. So, you know, we're doing everything from so far away, so it's a little bit more difficult. So I went ahead and I'm deleting these because they're added in. I went ahead and I set it all up for us. So we don't have to do everything from scratch. A lot of things are already labeled and set, but we do have a data set, and we are going to have to count up the frequency to create a frequency table. And then from there, we can go on. Now, if you're using the digital version of the notes, then you've got all what I have right here. This is just a copy of it, and we're going to drag and drop, kind of like how we drag and dropped our box plot activity. And so it's a little bit more interactive. If you have notes that are printed, you can just draw it, okay, and make sure that your histogram bars are equal width, okay? So you're gonna have to be a little more careful. All right, so look, here's a data set. A lot of times they show it like this. So what we're gonna do is you're gonna help me count them up, and we're just basically, it's like finally, math is this simple. We just get to count. Okay, we're gonna count how many numbers fall within a 0 to 4 range. Okay, so just kind of scan it. You have to be careful though, guys. When things get simple like this in math, there's a good chance you're gonna make a little error because we are humans. Okay, so 0 to 4, at least we have 73 people that we can rely on if we make mistakes, especially Miss Melanie. So 1, 2, 3, it looks like 3 numbers fall within 0 to 4. Again, it doesn't matter that there's no 0. Sometimes when kids make intervals, they're like, well, I have to start exactly at the first number in the data set, at that minimum. Notice our data set doesn't start till 2, but they started at 0. Well, it's because they wanted to give an equal chance, have those equal intervals, and 0 is a good place to start, okay? So they just went 0 to 4, 5 to 9, and so on. And so basically the beginning of each interval is 0, 5, 10, 15, 20. So those are always a good, that's a good starting point for your intervals, like counting by 5s, start each number, the first part of the interval, being a 0 or a 5, you know, ending in 0 and 5. Those are good places to start, or maybe starting each interval at 10s or starting each interval at 100s, and then going up to that 9 point, okay, or up to the 4, you know, and so on. So it's kind of difficult making intervals, but we lucked out here. So 5 to 9, any numbers between 5 and 9. 1, 2, 3, 4. That's it. Crickets. And again, chat me if I make mistakes. Okay, or raise your hand. I'm trying to keep track of that. And then here we go, 10 to 14. 1, 2, 3, 4, 5, 6. And then 15 through 19, that would be 1, 2, 3, 4, 5, 6, 7. And then what I do to double check is I add up all of the numbers here, all the values, all the frequencies, let's say. So 7 plus 3 is 10, 4 plus 6 is 10, so that's 20, and this is a 5 by 4, so that's 20 numbers. So boom, I made sure I counted all of them. Okay, do you get that? So now we've got frequency. So now this is what you're graphing on a histogram. This is why it's different than just a bar graph, okay? And now if you were to have to make this from scratch, I would have had to decide, okay, what are my frequency numbers? 3 is the lowest, 7 is the highest. So I'd have to decide on my y-axis over here to only go from 0 to 8. I could have gone up to 10. You're just going to have more blank space at the top. If you only stop at 8, then you've got a more zoomed in histogram, okay? Now, what I want to point out, though, guys, is that they didn't stop at 7, okay? Even though 7 was the highest number, they didn't stop at 7, and it's not just because 8's even. You don't really want to stop at the ending number. So even if 8 was that last number, I wouldn't really want a bar going all the way to the top to my title. So you kind of want to add a little buffer space there by adding another number. Not too much buffer space, but just a little bit. And again, I didn't number this from 0 to 20 and have all my bars be in the lower part of my graph. You want it nice and zoomed in. Okay, so now, of course, I want this in rainbow order. You're going to go ahead and drag your bars, or draw them if you're using the printable version, and we're going to adjust the size of them. So I don't want to adjust from the top right corner because that would change the widths, and I want my widths to be equal. So I'm going to adjust from this top middle dot, okay? And I'm going to make it go up to 3. So click the top middle dot and drag it up a little so that it goes up to 3. All right, so now the next one's got to go to 4. So I go drag it over here. Remember, there's no space on these, so we're going to squish them in. And if we do have to do an adjustment, I kind of eyeballed it, then we will adjust the width. Okay, so this is going to go to 4. I need sound effects in post. Okay, and then 10 to 14. Uh-oh, see, it's a little narrow. We'll make it work. Okay, so 10 to 14 goes up to 6. And then 15 through 19 goes up to 7. And if I were going to be a perfectionist and turn this in or something, I probably would widen these, but I'm not going to do it. Guys, I'm going to let it go. Just let it go. Let it go. Okay, that's recorded on YouTube now. Great. Okay, so I'm going to go up to 7. All right. And if you want to double check again, you can add these values up over here and make sure they add up to 20, but I'm pretty confident we did that. And we've got, oh, what kind of histogram is this? Somebody's asking me not to sing again. Okay, so what kind of histogram is this? It's going like this. It's pulling towards the left here. Okay, so it's skewed to the left. It's, you know, pulling to the left. It's left-tailed. All right, where most of the data is to the right, but we've got some data that's pulling it towards the left. So that's skewed left. All right, let's move on to another one. And if you guys are behind or anything, remember you can always go back and take a look at this. And you know what? Probably when I post this slideshow on Edsby, I'll post the finished version. All right, you ready? Number of minutes spent on homework daily. All right, let's go ahead and count these suckers up. So we're going to count the frequency. How many of these? So that means how many students, each one of these data values represents a kid that answered this survey question. And we had some trouble with that. A couple of people said I don't have the notes. They're on Edsby, guys. They're always on Edsby. So you got to just open up another tab and click it on to Edsby. But anyway, so look, guys. So on the line plot test, like the quiz we took on Socrative, some people were having trouble like realizing that every X on the line plot or every dot on a dot plot really represents an answer to a survey question. It represents an answer to that question. So if they say how many students or how many people are in the gym, I believe one of the questions was, all you had to do was count up how many dots there were because every one of them was a potential answer, okay? All right, so here we go, and we're gonna count up 0 to 9, 1, only 1. Okay, so they included this interval even though there was only one person that answered 0 to 9. That's okay. All right, and then 10 to 19. 1, 2. So anything within the teens, right? So 1, 2, 3, 4, 5, 6, 7. Only 7. All right, anything in the 20s? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe it's 9. I went a little fast there. And then in the 30s, 1, 2, 3, 4, 5, 6. All right, now let me count these up. So 9 plus 1 is 10. Okay, 7 plus 6. I don't think we did this right. I did something wrong. I got 10, not 9. Yeah, I knew I was making a mistake there. Okay, so I knew it was wrong because it was going to end in a 3, and there's no way it could have, right? So 10 plus 13, so we have 24. So 6 by 4 is 24, so we're good now. I'm going to go ahead and call, I believe Matthew has a question, so I'm going to unmute him and call on him. Matthew? You have a question?
No, I raised my hand because I wanted to give out answers.
What'd you say?
I raised my hand because I wanted to give some of the answers, but you already did.
Okay, thank you. In just a minute, when we play, when we do IXL, I'll call on you and you can help me out if you want to raise your hand again, okay?
Okay.
All right, hi Matthew, bye. Miss you. Okay. All right, so let's keep going here. So the frequency, we're going to drag and drop these, or again, if you're using the printable version, you're going to just draw them. And put little, if you're drawing these on printable, if you're using the printable version, one tip I can give you is putting a notch like halfway in between each of these intervals, like a little notch, boom, boom, boom. And then basically grow up the bar, okay? I always teach my students that. Put those little notches so that the notches are equally spaced, and then basically just grow up the bar. That way you know that they're gonna be equally spaced. All right, so this needs to go to 1, so I'm gonna have to shorten it. Uh-oh, no 1. There's no 1. What am I gonna do, guys? That's right. You're gonna go halfway. Okay, so 1 does exist. I promise you. A lot of times students will be like, it's not there. It does not exist. I promise you 1 did not disappear. It does exist. No, this is gonna annoy me, so I'm trying to. Ugh, I can't get it right on the line. It's gonna drive me crazy. It's okay, Miss Melanie, let it go. I won't sing again. All right, so 10 to 19 is 7. So I'm going to bloop and bring it up to 7, which is halfway in between 6 and 8. And then we have 10. Zoop. Oh, looking like a little skew action is happening here. And then, oh my goodness, this one was too wide. It's okay that it goes off a little bit, folks. All right, and then we have 6. Bleep. Okay, so we got a peak here. 20 to 29 is our peak. We got a William peak. All right, so how we doing here, guys? You got that? We good? Give me a thumbs up. All right. We are going to now move to the next skill. Okay, so before we move to the next skill, though, I just want to review a histogram. Okay, start with a frequency table. Now, this is not a frequency table. This is, excuse me. And I want you guys to look at this. I'm quick draw McGraw with the arrows. Okay, so look, that's a frequency table. Over here, this is just your data set that they kind of put in a little, you know, a little table. But this is your data set. You start with it. You basically have to decide the intervals usually. Here, these are 4 of them. 4 is not the best. Okay, these 2 histograms have 4, and it's okay. But if we had 5, our data would be shown a little bit better. So ideally, you want 5 or more. Okay, but I see why they would want to do 4 because it just worked out so good with counting by tens. But you usually want between like 4 and 8 intervals in a histogram, okay, to make it interesting. Oh, there's some cool histogram apps. Now, and by the way, remember your bars have to be continuous. So really it should just go all the way up to both sides. Okay. Now this one overlaps. It's not going to drive me crazy. I'll shorten it a little bit, but it's okay. All right. So it should look like that, just like that one goes. Now there's some really cool apps out there on the internet for histograms. You can just enter in the data set and it will construct a histogram and you can say how many intervals you want. What's cool about it is you can change the number of intervals, like 5, 10, 8, and see how crazy different the histograms look when you change just the number of intervals. It's pretty cool. So check them out. Maybe I'll post a link to one of them or something. All right, so now let's get to statistical versus non-statistical questions. So here, and if you have any questions on histograms, by the way, guys, or any math questions, please come to my office hours. Not a lot of people are coming with questions. And the people that do come with questions leave with lots of answers. So like I'll sit there and help you with your assignment. These people will get serious one-on-one tutoring and it's really valuable. But if you don't show up, you're not getting it. Okay, every single day I do that for an hour. And it bothers me because so many people don't show up. And then I'm like, but then they need so much help, but they're not showing up for the help. I want you to come. I want to help you. Okay. And you could just be one-on-one. I'll put you in a breakout room. It's not like you're going to even have the other people there. All right. So I said my little spiel. Come. Statistical versus non-statistical questions. How do we arrive at questions that we can use in all the statistical displays we've been learning about? We learned about box plots, line plots, dot plots, frequency tables, histograms. Even on IXL, they went back and did a throwback on you that I wasn't expecting, and they talked about stem and leaf plots, which is like a throwback to 5th grade. So all those different things, the way that we use them, we have to have a statistical question. So what you need to know is you have to be able to know the difference between what is a statistical question and what is not. Okay, so we're just identifying which one is. Now, think survey questions. Survey questions are statistical questions. So anything that sounds like a survey question is going to be a statistical question. Let me show you what I mean, okay? A statistical question is a question that if it can be answered with a data that varies, so it has to have that variability. That means lots of different, maybe not lots, but many answers, at least a handful of different answers. You don't want a question that just has a yes or no answer, or that a question that has only one potential answer, or maybe 2 or 3 potential answers. For instance, if I asked, what's your favorite subject in school? That's a statistical question. Now, you might think, but wait a minute, how is that statistical? It doesn't have a number answer. Well, has answers that I can then count up the frequency of, and then I can show that on a graph, okay? That would be a categorical answer, so it'd be a bar graph, but it's still statistical question. Now, your answers like, what do 7th graders prefer to eat for lunch? That's a statistical question because I can have many different answers. What time did the students in this class get up in the morning? We're gonna have a bunch of different answers on that. What is the typical number of pets owned by students in my class? Several different answers. Again, like, how many siblings do you have? Several different answers. But if I say something like, what grade are you in? And I ask you guys what grade you're in, you're all gonna say 6th grade. Okay, so that's not gonna be a statistical question to you guys, to a sample, a small sample. Now, if I did a random sample, you're gonna learn about that next year in 7th grade. A random sample would be, I would knock on the people's doors all through my neighborhood. Okay, and I would ask them all, how old are you? That is, I'm gonna have many different answers. If I ask you guys how old you are, or how old a typical 6th grader is, I'm only gonna get maybe 3 answers, okay? So that's not, it doesn't vary enough. A non-statistical question would be, what did Tom eat for lunch? Or what time does Miss Melanie's Zoom start? That's not statistical because there's only one answer. Okay, everyone, you can ask 100 people that, but they're all going to answer the same thing, especially if, you know, obviously they're all talking about the same time. Did you get up on time this morning? That's a yes or no question. That's not statistical, okay? How many brothers does Martha have? So if I said, how many brothers do you have? And I asked a bunch of people that question, I'm going to get a lot of answers. That's statistical. But if I say, how many pets does Kate Murdoch have? That is just an answer. And especially if everyone knows the answer, right? You can't just guess. You'd have to give it one answer and everyone would say the same thing, okay? So a statistical question sounds like a survey question, whereas a non-statistical question sounds like it's just a question that has a right or a wrong answer to it, okay? Like, you know that there's going to be only one answer. So I've got some like doodle notes for us here. And this is included in the guided notes that you downloaded. Here it says statistical. If you printed this, you can color it, of course. It can be answered by blank. And we're gonna put many answers to show variability. That sounds like a big word, but it's got that word vary in it. We learned about vary from variables. Remember, variables have many different values. Well, variability means that things differ, they vary. So it can be answered by many answers to show variability. Oh, well, look at this. I kind of did a spoiler here. The data will have, guess what the answer is? Variability. Okay, so the data is going to vary. It's going to show some variability there. Write your own statistical question. So I'm going to call on someone to come up with one for me to write, but you guys can go ahead and write your own. Here are some examples. How many minutes do 6th graders typically spend on homework each night? That's going to vary. How many books does our class check out of the library every month? That's going to vary because each month is going to be different. Okay, so try to come up with your own statistical question and raise your hand, and I'm going to go ahead and call on someone. I'll call on Braden. Braden, what's a good statistical question that I could ask?
So what I put is, how many hours do college students stay up studying?
How many hours do college students stay up studying? Oh my gosh, that's going to vary. How many hours do college students stay up studying? Yeah, that's totally going to vary on the student, right? Just like it would vary if we were talking about 6th graders. Every student's so different. So that is a great statistical question. And you could go around to a college campus and ask them and come up with a random sample of just maybe people that walk up to you or you walk up to them. You always want a random sample of things unless you're trying to find specific answers like USF students, USF seniors. You know, if you want a specific answer, you would, you know, target that specific group. But if you want a random sample, you would have to kind of make it really random. And you're going to learn about that next year, about random samples and all that jazz. All right, so now let's go to non-statistical. This was like a one-page sheet, and I kind of cut it in half, so it was in slides. Non-statistical often has only one answer. Okay, so oh my gosh, shout out to Ayla. How many music videos has Taylor Swift made? Oh my gosh, Ayla, do you know the answer to this? Because we need you right now. Are you here, Ayla? Let us look, because we need you. Raise your hand, Ayla, so you go to the top of my list. Come on, show yourself. We need the answer to this. There's only one answer. Even if you don't know it, you can say anything and we will totally believe you, because we don't know. I'm gonna call on you. Can you say it, Ayla? I know you just chatted it to me, but can you tell everyone?
Probably about 100, because she has less music videos than her actual songs.
Yeah.
And we're just taken off because of reasons. But
oh my gosh. So probably about 100. We're going to have to look that up to find the exact. Yeah. So it's just going to be, it's a true answer that you can look up. If you have a true answer that you can look up on Google, that's a great point, because in your generation, you could just ask Alexa, ask Google. If it's something like that, it's not a statistical question, because it's got one true answer. Thank you, Ayla. I'm sorry I put you on the spot like that. Thank you. Okay. So let's write our own non-statistical question. So like, how many letters are in my name, or something like that, something that has a true answer. Okay. Let's see. Raise your hand if you want to share. Let's say her. I'm going to call on Victoria. Hello, my dear.
Hello there. I just wanted to state that I searched up on Google or I checked on Google, and it said 54 music videos.
Ooh, okay, 54. We got an answer. All right, so very good. Thank you. See how quickly you guys live in a generation that answers are instant. That's why when you send us an Edsby message and you don't get an instant response, you're like, what? Miss Melanie's not Alexa? I try to be, guys. I try. But yeah, thank you for pointing that out. Victoria, can you also give us a non-statistical question, something that has like one answer to it?
Ooh, how many students are in the 6th grade?
Okay, good. How many students are, and I'm going to make it even more specific, how many students are in LG's 6th grade? Because if we make it more specific, then it's even more accurate, because it's not like a typical 6th grade class, 6th grade group. It's now, we're talking about learning gate. Sometimes changes as kids come and go, but it's a non-statistical question. We can find the answer out. If you don't know the answer, you can look up the answer. That's not statistical. So hopefully you guys get this a little bit. We're going to go ahead and do some practice before we go. Okay, so I'm going to go ahead and bring up IXL, and hopefully the internet will be nice to us. All right, so here we go. Raise your hand, lower your hand if you don't want to be called on, because I'm about to call on a lot of people. Go ahead and raise your hand if you want to help me identify statistical questions. And if you want to play around with this, the shortcut to this skill is PT7. And remember, you can always find my search shortcuts for IXL skills right there in Edsby when I assign them. They're right next to it in parentheses. So go ahead and look for those there for the ones for this week. All right, so is the following a statistical questions? How many yards are in a mile? That's not statistical. Why? Because there's an answer to it. There's a clear answer. There's one true answer. So no, not statistical. Statistical is going to be like a survey question. It's going to have a varying group of answers. Okay, is this one statistical? How many points do professional basketball teams score in a typical game? Wow. Is any game really typical, guys? That's definitely statistical, because you're not going to have the same answer every time unless you give a range of answers, I would say. I hope this is correct. I'm saying yes, it's statistical. All right, how many days are in April? No, that's an answer. Like, I can look it up, and I know that you know, years change, but April doesn't change anything. Okay, 30 days has September, April, June, and November. So 30 days. The answer is 30. So that's not statistical. All right, and I'm going to zoom out so I can see my SMART score. How often is a typical student at your school absent? How often is a typical student? Again, not really a typical answer. It just really depends on the student. So I'm saying, yeah, that's statistical. I could say 0. I could say 6 days. I could say 10 days. I could say 2 days. That's statistical. All right. How tall are palm trees? There's a range of answers, isn't there? Okay, so if there's a range of answers, it's statistical, because that means you can make intervals and you can start measuring a bunch of palm trees. Okay. How long are great white sharks? Again, it's a range. If we look it up, it'll say like 8 to 10 feet or whatever it may be. I don't know, that came off the top of my head. But yeah, it's going to be statistical because it depends on the shark. We can go out there and start measuring. How many letters are in the English alphabet? There's no question about that. We know the answer, so that's not statistical. How much was Hazel's electricity bill in January? That's an answer we could find out. We go find Hazel, we go find her electricity bill, and we look in January. So we have an answer to that, so it's not statistical. If we said how much was Hazel's electricity bill each month, that would be a range of answers, because you could have 12 potential answers. In what year was your father born? So try not to overthink all these too, guys, okay? Because it's like, someone brought up something that was good. They said, well, January, what year? There's a lot of Januaries. Just like, don't overthink it too much. But yes, you are right. If you would say like, how much is Hazel's electricity bill in a typical January or something like that, then that would be statistical, because a typical January would mean, okay, I'm thinking of a bunch of Januaries. But in that last question, I could tell they were thinking about one January, if that makes sense. So just don't overthink it too much. If in what year was your father born, you could look this up. Okay, you can ask him. So no, not statistical. We're at 70. What is the freezing point of water in degrees Fahrenheit? Again, I can ask Alexa, so it's not statistical. Which team won the first Super Bowl? I can ask Alexa, not statistical. How many quarts are in a gallon? I can ask Alexa. Hopefully I will know that. What is the answer to that? Anyone know? What's the answer? How many quarts in a gallon? Quarts in a gallon. Do you remember the big G you wrote? Like, anyone ever do like that gallon man thing? And then you had to put 4 Q's that fit inside the one big G. So there's 4 quarts. That's the first thing that comes to my head. So 4 quarts in a gallon. Good job, guys. Good job, Jordan and Maddox and Kate and Jake. 4 quarts in a gallon. So we have an answer. So it's not statistical. We're at 82. What's the typical? You see how they use that word typical? Because they're saying there's lots of answers. What is a typical number of books that 6th graders read over the summer? There's a range of answers, because there's not a typical 6th grader. You know, every 6th grader is different. So that is a statistical answer. How much time do 6th graders spend online? You guys are all different. Some parents have stricter rules, some parents don't. Okay, right now through quarantine, we're all spending way more than we would ever spend. Okay, so this is statistical. And then we're almost there. I just want to get to the end. I know you guys want to leave, and really, truly, you could. Just remember, the thing you need to know that I want to remind you is that your IXL skill GG 11, 6th grade, is due by Friday at 11. So make sure you have that done. And if you want bonus credit, use it by doing that extra skill that I posted on Edsby. What's your best friend's favorite color? Your best friend's favorite color. Well, I'm going to argue that this is statistical. Oh gosh, if you're asking a bunch of people this, it would be statistical because they would all have a bunch of different best friends and they would all have different favorite colors. But if this is talking about like me and my best friend's favorite color, that's going to be only one answer. So I'm very interested in seeing what it's going to say for this question because I could argue both points. I feel like I need more information. What's your best friend's favorite color? I'm going to say it's statistical because I'm going to say that we're asking a group of people this question. Oh, it's wrong. All right, listen, IXL, I've got beef with you. Let's see what it says. A statistical question requires data to answer it. The data is expected to vary. So what's your best friend's favorite color? The question has a single response. It is not answered by looking at data that varies. So this is not statistical. Well, I argue with you. I will have a debate on this, IXL, because the question, if asked to many people, has not a single response, but a varied response. So that's another letter I'm going to have to write that in on my long list of writing letters to companies. Okay, we're almost there, guys. Oh man, I just don't like that. How many cars does your family have? Again, I guess the answer is just very clear, but if I ask you guys this, there's going to be a lot of different answers. So I guess it's expecting that I'm just one person on the other end of this IXL and that there's not, 50 people with me. So I guess I'll say no based on how they answered the last one. Okay, good. Okay, so they're expecting that I'm just one person at the other end of this computer. We got to keep that in mind. What is a typical quiz score in your math class? Oh, that's statistical. All right, I'm going to get to 90 and then stop because of the time. How many seconds are in 1 hour? Not statistical because I can look it up. And we got to the challenge zone. I'm going to go ahead and stop there. And so, guys, make sure you go back and review. I've got somebody at my door. This is so quarantine. Okay, so on your own time, you want to have these two things done. If you are looking for the shortcuts, it's CBF for the one that's for grade, and then the IXL skill that's a bonus credit is MFY if you want to write down those shortcuts. Again, the graded one, whatever you stop at, that's your SMART score is your grade out of 100. That's worth a lot in the grade book. And then the bonus credit, you can get to 80 and you get 4 points added to your quiz. If you get to 100, you get 6 points added to your quiz. Please join me in my office hours if you do not understand something. Okay, so please, please, please come. Ask questions, young ones, okay? Because you would be asking me lots of questions if we were in normal life. So I want to make sure that you're still learning. So come ask questions, okay? See ya. Bye. Bye, bye, bye. Have a good day.